So we're finishing up 6-8, which will finish Unit 6. Which means next Monday, Tuesday, we'll review. Thursday, Friday, we'll test. Not Thursday, Friday. Wednesday, Thursday, we'll test. Because there's no class on Friday. All right, so looking at F. Here we have the antiderivative from 0 to pi of e to the cosine x sine x, right? And so when you look at this, we know we can't take the derivative of sine to get cosine in a numerator, right? So when you're trying to figure out which one to let be u, you're going to have to use that exponent, yeah? I said numerator, but I meant exponent. So here, if u equals cosine x, du equals negative sine x dx, right? And I have the sine x, but I really need the negative in there, don't I? And so if I need the negative in there, I have to put a negative out here as well. If x equals 0, u equals cosine of 0. And so that would be 1. Do we agree? And if x equals pi, u equals cosine of pi, and that would end up being negative 1. Do we agree with that? So in terms of u, this would be negative 1 times the antiderivative from 1 to negative 1. We have to go from our lower to our upper bound of e to the u du. And because my lower bound is bigger than the upper bound, I have to do negative 1 times negative 1, don't I? From negative 1 to 1, e to the u du. Well, a negative and a negative we know is a positive, and so I just end up with the antiderivative of e to the u is e to the u from negative 1 to 1, correct? Which would give me e to the first minus e to the negative first, or e minus 1 over e. Realize that you could also see this as e squared minus 1 all over e, right? Because that would have been a common denominator. Or you could see it in the decimal form if it was calculator based. Make sense? All right. Evaluate by completing the square. Okay, so when we look at this one, if I let u equal my denominator, I know I can't get du because I can't get 2x plus 12 in the numerator. Do you agree? So I can't do that. So then that gives me a hint that I'm going to have to do something else. Yes? And so in this case, the only other thing I could possibly do is complete that square because I need something squared in the denominator. Yes? So if I group these two, I know I would get x squared plus 12x plus half of 12 is 6 squared, which means I'm adding 36, which means I need to subtract 36. And so then this would be what? X plus 6, the whole thing squared, plus 1. Is that fair? So now I'm looking at the antiderivative of 1 over x plus 6 squared plus 1 dx. Now the problem with this is we think of that as probably 1 over u squared plus 1. Do you agree? And so remembering that the antiderivative of du over a squared plus u squared is 1 over a inverse tangent of u over a plus c. So here, a would equal 1, u would equal x plus 6, du would equal 1 dx, right?
Would the a just be from the plus 1?
Yeah, the square root of 1 is 1. And so then we'd have 1 over 1, because it's 1 over a, inverse tangent of u over a, so x plus 6 over 1 plus c, which would just give us inverse tangent of x plus 6 plus c. Does that make sense? Questions? Okay, looking at b, again, if I let what's under that denominator equal u, I'd end up with negative 2x plus 4, right, for my derivative, and I can't get that in the numerator. And so I'm going to have to do something else. And the only other thing that I could think of that might work would be completing that square under the radical. Because I know if I have 1 over a square root of a squared minus u squared, that's one of my identities. And so the antiderivative of du over the square root of a squared minus u squared is inverse sine of the absolute value of u over a plus c. Okay, so here I want my x squared to be positive, so I'm going to factor out a negative 1. That'd give me x squared minus 4x plus, to complete the square, half of 4 is 2 squared. Right now there's only 0 on the outside, right? And so then here I'm adding 4 squared multiplied by negative 1, so I'm really subtracting 4 squared. So on the outside I'd need to add 4 squared. Does that make sense? And I probably need it in the reverse order because that's what my form looks like here. So 1 over, this would be the square root of a, which would be 4 squared, minus b, which would be x minus 2 squared, not b, u. Yes? And I have the dx still. So here, not squared, that's not squared, it's just 4. Sorry, 2 squared is what I was using. So a would be 2, right? Square root of 4 is 2. And u would be x minus 2, which means du is 1 dx, which I have the 1 dx. And so I'm looking at 1 over the square root of a squared minus u squared du, which would give me inverse sine of the absolute value of u, or in this case, absolute value of x minus 2 over a, which is 2, plus c. And I do need my absolute value there because there's a variable inside of it, right? Questions? Okay. All right, here's some challenges. If we look at this, that doesn't really look like any of those special things to me. And so I'm going to have to just try some stuff. So if I let u equal my denominator, and I'm going to write that as 2x to the 1/2. Du would equal, derivative of 1 is 0, so I don't have to mess with that. But here I'd have to have 1/2 times 2x to the negative 1/2 times the derivative of the inside would be 2, correct? Make sense? So here, I would say du would have to be 1 over the square root of 2x. Which I don't have, do I? So then, what else could I do? If u equals 1 plus the square root of 2x, square root of 2x would be u minus 1, wouldn't it? Is that true? What else do I have here? Oh, and I have to have a dx here, don't I? So if I was to try and get dx by itself, this would be the square root of 2x du equals dx. Is that true? Yeah? So here, if I look at that, I've got to have something for dx, yes? Is that fair? I mean, I can see this is 1 over u, but I've got to have something for dx in terms of u, don't I? Yeah? Because I can't have a mix of variables. So if dx equals this and this equals u minus 1, is it fair to say that u minus 1 du is equal to dx? Would that be fair? So if that's true, then I'd have the antiderivative of 1 over u minus 1 du, wouldn't I? Would that work? Well, then here, this would be u minus 1 over u du, which would give us u over u is just 1 minus 1 over u du. Is that true? So the antiderivative of 1 is u, and the antiderivative of 1 over u is natural log of the absolute value of u plus c, correct? Well, what is u? 1 plus the square root of 2x minus natural log of 1 plus the square root of 2x plus c. So that would be true, but you could also see that since this is a constant, your constant could absorb that 1, couldn't it? Because a constant's a constant no matter what it is, yes? So you could also see it as 2x minus the natural log of the absolute value of 1 plus the square root of 2x plus some other constant. Of course, this c is not the same as this c because we've added 1 to it, but it's still a constant. Does that make sense to you? So if your constant just disappears, that's still a possibility as long as you have plus some c. Okay, let's look at it in terms of this. This one's, I think, a little bit easier, though. Because here, if I let u equal 3x plus 1, du is simply just 3 dx, right? And I know I can bring the 5 out in front because it's just a constant, isn't it? So I know I'm going to bring the 5 out in front. This is from 0 to 4 of 1 over 3x plus 1. I need a 3 dx, which means I have to put a 1/3 on the outside there. And now to put this in terms of u, I have to change my upper and lower bounds. So if x equals 0, u equals 3 times 0 plus 1, right? Which means this would equal 1. And if x equals 4, u would equal 3 times 4 plus 1, which would be 13. Do you agree? So now I have 5/3 times the antiderivative from 1 to 13 of 1 over u du, which would give us 5/3 times natural log of the absolute value of u from 1 to 13. So natural log of 13 minus natural log of 1. I don't need the absolute value because both of those are positive, right? And we know the absolute, or the natural log of 1 is 0, isn't it? So I really just get 5/3 natural log of 13. Does that make sense? So that A is the one that was pretty challenging, yes? And we just had to keep working until we found something that we could make work. The big thing is you can't have a u and an x in the same problem, right? If you're going to do a u substitution, you have to do a u substitution for all x's, including the dx. So our problem is that when we did du, we still had something that we couldn't have, right? So we had to figure out how to manipulate that to make it work. Good?